from among the different techniques of integration, we are now on the second one, which is algebraic substitution. By the way, this is not actually number two. It can go, it can be in any order. It's just that I wanted to start with integration by parts, followed by algebraic substitution. If the integrand involves fractions, kasi we've been doing substitution before, the U substitution. But in this case, if for example, you have a certain integrand with u of x and then it has a power, what we do here is we try to make it in the form of u equals z to the n, where n is the least common denominator of all the fractional exponents. So how is that? For example, this one, you know that your x, kasi if you choose any of the two, you won't be able to get the differential, the du. So in this case, it says in here, the least common denominator of all the fractional exponents, if it involves exponents with fractions. So what we do here is, let's just say 1/2 and 1/3, guys. What's the LCD of 1/2 and 1/3? 1/6. So since 1/6 is the LCD, what we do here is, let z be equal to x to the 1/6, because it's x that contains the fractional powers. Therefore, I can say that z to the 6 is equal to x, right? So in this case, if z to the 6 is equal to x, I can say na 6z to the 5 dz would be my dx. Also, look at this. I'll cut that. In here, you have an x to the 1/2. You also have an x to the 1/3. So your x to the 1/2 is actually z to the 6 raised to 1/2. That is z to the 3rd. This one is z to the 6 raised to 1/3, which is z squared. So if we substitute everything using algebra, my dx will then be 6z to the 5 dz. And then at the bottom, my x to the 1/2 would be z to the 3rd. And then my x to the 1/3 is z squared. So how can we solve this? First, I don't need a 6. I can say that's z to the 5 dz. And then the one at the bottom, guys, I can factor out the z squared, leaving me with z plus 1. So with this, you know that you can cancel out terms. Cancel the z squared. This becomes a z to the 3rd. But still, the numerator is greater than the denominator. This is an improper fraction. Z to the 3rd divided by z plus 1. That's z squared. That's minus z squared. You can still divide. So minus z squared minus z. Bring this down, change the signs, and then you can still divide. Z plus 1, you change the sign. So what's left is -1 at the bottom. So here, I could say that this one can be rewritten as z squared minus z plus 1 minus 1 over z plus 1. So here, let's try to integrate. Let's move the 6 out. The z becomes power rule, z to the 3/3. Again, power rule, z squared over 2 plus z minus, this becomes an ln. Z plus 1, close, and then plus c. Now, guys, my original problem is not in terms of letter z. It was in terms of letter x. Therefore, I can say this one is 2/3 What is z cube? Oh, it says there, z cube is actually equal to x to the 1 half minus 1 half, sorry, 6 divided by 3 is 2. So this is 2. 6 divided by 2 is 3. And then z squared, you can see here on top, z squared is x to the 1/3. 6z, what is z again? That's x to the 1/6 minus 6 ln of x to the 1/6 plus 1 plus c. All right, let's move to the next. This one, as I said, which one should be the main? Usually, isn't it, guys, the more difficult one? So let's just say we let u be the more difficult one, which is x plus 2. So again, using the substitution, I can safely say that u squared is equal to x plus 2. So guys, I'll ask you, why did I not make it a power rule? Because if it's a power rule, I would need another square root or something like that. So maybe we can try the u substitution and then algebraic substitution. So this one, if that is the u, I can say that 2u du is equal to dx. However, in here, don't forget that u squared minus 2 is equal to x, right? So let's substitute everything. So we have an x on top. So your x would be u squared minus 2. You have a dx. The dx is 2u du over x plus 5. So ang x plus 5 natin is u squared minus 2 plus 5, the one at the bottom. And then square root of x plus 2, which is actually your letter u. Okay, let's cancel what we can cancel and simplify what we can simplify. So here, you know that you don't need the 2. Bring it out. On top, that's u squared minus 2. At the bottom, that's u squared plus 3. So again, this is an improper fraction. So let's do the long division. So that's u squared plus 3. And then since we're subtracting, change sign, you'll get minus 5. Okay? Therefore, this one can be rewritten as 2 integral of 1 minus 5 over u squared plus 3 du. So we don't have a problem with the first one. The first one is simply u. However, for the second one, this one, guys, what is the form? This is in the form of arctangent, where u is u, a is square root of 3. So let's integrate 2. What's the integral of 1? Du. Don't forget, baka mamaya you might write x. We don't need the 5, so let's bring out the 5 muna. And then 1 over a, 1 over the square root of 3 arctan of u over square root of 3 plus c. And then let's bring in everything. 2u minus 10 over square root of 3 arctan u over square root of 3 plus c. But again, the problem was not in terms of u. It's in terms of x. So let's bring it back. 2 square root of x plus 2 minus 10 over square root of 13 arctan of square root of x plus 2 all over square root of 3 plus c. Some of you might ask, should you simplify this as 10 square root of 13 over 13. And then can you simplify this? That's 3. So let's go to the third. So again, in here, some of you might ask, sir, is it okay to use u is the square root of x? Let's try. Actually, I'll show you two solutions. Let u be equal to the square root of x. Therefore, u squared is x, 2u du is dx. So, in this case, guys, you can say, let's replace everything. The dx would then be 2u du square root of square root of x becomes u plus 1. However, when you try doing this, you still won't be able to integrate. Why? Because what if power? Okay. Let w be equal to, kasi we've already used u, di ba? N is negative 1/2. Let's use the bottom one. dw is du. Okay, sana. But, look, if it's power, dapat walang u on top. We have a u on top. So that means we can't use the power rule. So what we will do here is maybe another substitution. Let's just say z be equal to the square root of u plus 1. Therefore, z squared is u plus 1 to z dz is du. Right? Okay. So if we try this, integral of 2u du on top. So let's replace what is u? Z squared minus 1. So we don't need the 2. Let's bring out the 2. Letter u is z squared minus 1. The du is 2z dz. The square root of u plus 1 is z. So let's try simplifying what we can simplify. Cancel. And then let's bring out what we don't need. For integral of z squared minus 1 dz. So some of you might say, this is already integrable. Yes. So that becomes 4 z cubed over 3 minus 4z plus c. What is z equal to? It says there z is u plus 1 square root, but then that's z cubed. So I can say square root of u plus 1 cubed minus 4. The z is square root of u plus 1 plus c. The original problem, yes, it's in terms of x. Therefore, you have to bring it back. Square root of what's letter u? That's square root of x plus 1. This is to the third power minus 4 square root of the square root of x plus 1 plus c. Now we are back. What methods did we apply here? Let's call this method number 1. So what did we apply in method number 1? First, I applied the u equals square root of x sub. The second that I applied is z is equal to square root of u plus 1 substitution. So that means in here, in your first method, you actually did 2 substitutions. Is there a possible way in which we will not have to do 2 substitutions and just do 1? I'll show you another way. So the original problem, let's rewrite that. Square root of dx all over the square root of the square root of x plus 1. So What if I selected my u as the square root of x plus 1? What if I did this? Let's try. U squared will be equal to the square root of x plus 1. Therefore, u squared minus 1 is equal to the square root of x. So, u squared minus 1 quantity squared is your x. And then let's try to get the differential of this one. 2 u squared minus 1 times 2u du. Let's rearrange everything. For u squared minus 1 du is your dx because we will need it to be arranged properly when we do the substitution. The dx is equal to this. And for u squared minus 1 du. And isn't it the whole denominator is equal to letter u? Therefore, cancel. I don't need the 4. Let's bring it out. You're left with u squared minus 1 du. And then, what's the integral of u squared? U cubed over 3 minus u plus c. And then let's plug in everything. 4/3. What is u equal to? Square root of the square root of x plus 1 cubed minus 4 square root of the square root of x plus 1 plus c. Isn't that the same answer as this one? But then we only did one substitution. So this is what you call method 2, where we did the substitution of the whole denominator. So let's try another problem. If we let u be equal to the square root of x, you can see that u squared is x, or 2u du is dx. So let's try. This becomes u. And then dx is 2u du. So when we rewrite that, 2u, just by the form itself, what is this? This is integration by parts. So IBP siya. In IBP, remember, liate, you have algebraic and trigonometric. Which comes first? Algebraic. Therefore, let us try. Let u be u. Let dv be sine u du. So the du here is just a du. The v is negative cosine of u, right? So let's do the integration by parts. We don't need the 2. Let's bring it out. uv, so negative u cosine u minus the integral of v du, right? So in here, 2, let's do this first. Cosine u. So that becomes plus. What's the integral of cosine? It becomes sine of u plus c. Let's bring everything inside. Negative 2u cos u plus 2 sine u plus c. But then what is letter u? U is square root of x. We're using the u substitution. Plus 2 sine of the square root of x plus c. So in here, you have 2 methods. Number 1, the algebraic substitution, and then Second technique that we applied is integration by parts.